So we're going to write the relation for this function that we see graphed over here. And you can do this in a couple of ways, but we're going to show you one of the strategies in order to complete a question like this. Now, before we go to the strategy, our strategy really is dependent on the linear function formula, which is y is equal to mx plus b, where m is the slope of the line or the rise over the run, and b is the y-intercept, and that is specifically the part of the graph which crosses over the y, or the part of the line, I should say, which crosses over the y-axis. So the first thing that we do is we try and get the y-intercept here, or the b value. And when we look at our graph, we can see that the line crosses at this part here, where the y value is equal to 4. So therefore we could say that b, this is over here, is the value for b is equal to 4. The second part of the strategy would be to get the slope of the line or the rise over the run. Now to do this, you can really pick any 2 points along the line. People tend to traditionally pick the first and the second point, and that's fine. You would get the same value. But remember, since this is a straight line with a constant relationship between the variables or constant first differences, it really doesn't matter which lines or dots you pick or points you pick. So what I'm going to do here is a little bit unconventional. I'm going to pick this point and this point, and those are the points that I'm going to work with to get my slope. For the first point, it's at -2 and 3. And this, of course, pertains to the x value, and this pertains to the y value. And then at the y-intercept, I have an x value of 0 and a y value of 4. Okay, so we read these graphs from left to right. So what I've done here is I put a subscript of 1s over here, so x1 and y1, and then x2 and y2, and of course the points that are furthest to the right, it refers to the second point. And so in order to calculate the slope, we could write that the slope is equal to your m is equal to your change in y over your change in x, which can be expanded into y2 minus y1 over x2 minus x1. Some people say it's the final y minus the initial y, or the final x minus the initial x. However way you want to phrase it, that's totally fine. So in this case, it's going to be 4 minus the first point of the y is 3, and then divided by your second x point, which is 0, minus -2. And don't forget to keep that negative in there, because if you drop that negative, you're going to end up getting a negative slope, and you would see that your line should slope down. So when we do this properly here, we get a slope of 1 over 2. And that's the m value. And so that gives us the final equation of y is equal to half x plus 4. And that's the equation of this line. So let's look at another relation where we're going to find the equation from the graph. So the first thing that we're going to do is we're going to get the y-intercept, or get the b. So remember that the b is the part of the line that crosses the y-axis first. Now it looks like there are 2 intercepts here. There's this one and there's this one. However, we don't really want this one because that's an x-intercept. We want the y-intercept, and it looks like it has a value of -2. So we're going to write b is equal to -2. Second part is to get the slope of the line, or the m part of the equation. Now, again, you can pick any points along this line. This time I'm going to keep it simple. I'm going to pick the first point and the last point. And of course, we read this graph from left to right. So on the left over here, I see I have a point at -6 for my x1 value. And it looks like it's a +4 for my y1 value. And then over here, I have +3 for my x2 value. And then I have a -5 from my y2 value. And so, of course, using the formula, m is equal to change in y over change in x, or we can expand that to y2 minus y1 over x2 minus x1. We're going to plug in -5 for the second y value, minus 4 for the first y value, over for the second x value of 3, minus the second x value, or the first x value, I should say, of -6. And so when we plug that into our equation here, we end up getting -9 over 3 minus -6 would give us a value of +9, which means that the slope is equal to -1. The -1, of course, here would be your m value. The -2 is our y value. And if we go back to the properties of linear functions, the negative does make sense because it just tells us that it slopes downwards, which we can see it most certainly does, right? The graph goes this way, so it should have a negative slope. And so this is the function or the relation for this graph over here. Now let's say we want to put this function on this graph over here, y is equal to 2x minus 3, and we don't want to spend time doing a data table or a table of values from -2 to 2 or -3 to 3. And on a test, that probably isn't always going to help you, especially if the test has time constraints. So what we're going to do for this one, if we're not going to use a table of values, then we can simply plot the y-intercept value first. And then the second part is going to be create 3 points from the b value using the slope value, or the m. So in this case, the b value is going to be at -3. And remember, it's a y-intercept. So wherever the line crosses the y, that means it's going to have an x value of 0. So that's going to be at 0 and -3. So I'm going to go ahead and do that right away in red over here. I'm going to find -3 at 0, and I'm going to plot that point here. Okay, and I'll make it kind of big so we can see it. Okay, so I plotted the b value. Now I'm going to create 3 points from the b value using the m value. So from here, and I'll highlight it, from here, I'm going to make 3 other points. Now, the m value, or the slope over here, whenever we write a value of 2, I want you to keep in mind that that can also be written as 2 over 1. Now that's important because for a slope value, you need a rise over a run, or we need the run. And when I write it just like 2, it doesn't seem so obvious that it has some sort of run. Now if I rewrite the 2 as 2 over 1, then of course the 2 over here is the rise, and the 1 is the run. And both are positive, and that's going to help us because what we're going to do from there is we're going to write the rise is by 2. So I'm going to move up 2 from the point, and then the run is a positive 1 over here. So up 2 and then over 1. And then my point is going to get plotted there. Then I'm going to do the same thing from that point. I'm going to move up 2 and then over by 1. And then plot my next point over here. So now that's that's 2 out of 3 points. And then from that point, we're going to go up by 2, right? Rise by 2. And then over by 1 for the run. And now my third point is plotted. Once I have that, I can connect the 3 lines here for that straight line. And then that line over here is the graph of that function. So I plotted the b value, created the 3 points using the slope from that b value, and that gave me the line of that function.